Hi guys, welcome back. Domain 6 Cryptographic and PKI, Chapter 6.1 Compare and Contrast Basic Concept of Cryptographic. So this is the list. In this video we're going to see cryptographic concepts. So cryptographic is the science of encrypting or hiding information, something people have sought to do since they began using language. Although language allowed them to communicate with one another, people in power attempt to hide information by controlling who was taught to read and write. Eventually, more complicated methods of concealing information by shifting letters around to make the text unreadable were developed. These complicated methods are cryptographic algorithm, also known as ciphers. The word cipher comes from Arabic word SIF4, meaning empty or zero. Historical ciphers were simple to use and also simple to break. Because hiding information was still important, more advanced transposition and substitution ciphers were required. As systems and technology became more complex, ciphers were frequently automated by some mechanical or electromechanical device. A famous example of modern encryption machines is the German Enigma machines from World War II. The machine used a complex series of substitutions to perform encryptions, and interestingly enough, it gave rise to extensive research in computers. When setting up a cryptographic scheme, it is important to use proven technology, proven cryptographic libraries, and proven cryptographically correct random numbers generated are the fundamental elements associated with the solid program. Homegrown or custom elements in this area can greatly increase risk associated with the broken system. Most groups don't possess the ability to develop their own cryptographic algorithm. Algorithms are complex and difficult to create. Any algorithm that has not had public review can have weaknesses. Most good algorithm is approved for use only after a length test and public review phases. When material called plaintext need to be protected from unauthorized interception or alterations, it is encrypted into ciphertext. This is done using algorithm and a key, and this rise in digital computers has provided a wide array of algorithms and increasingly complex keys. The choice of specific algorithm depends on several factors, and they will examine in this video. We will see that. Okay, so let's go for the topic: encoding versus encrypting. Encrypting data is the method by which plaintext or any other type of data is converted from readable to an encoded versions that can only be decoded by another entity if they have access to the decryption key. Encoding data is a process of transforming data from one form into another form using a known algorithm so that it can be reversed easily. So no key is required used to change human text into machine text. Example, ASCII. Cryptographic, the process of converting, as I explained before, the process of converting ordinary plain text into unintelligible text and vice versa. It is a method of storing and transmitting data in a particular form so that only those for whom it is intended can read and process it. There's a two type, diffusions and confusions. So diffusion is principle. First we go to see confusions. Confusion is a principle to affect the randomness of an output. The concept of operationalized by ensuring that each character of ciphertext depends on several parts of the key. Confusion places a constraint on the relationship between the ciphertext and the key employed, forcing and affect the increased entropy. Diffusions is a principle that the statistical analysis of plain text and ciphertext results in a form of depressions rendering rendering one structurally independent of the others. In plain terms, a change in one character of plaintext should result in multiple change in the ciphertext in a manner that change in ciphertext do not reveal information as to the structure of the plaintext. Okay. Algorithm: a process or set of rules to be followed in calculations or other problem-solving operations. Keys: secret value used with an algorithm encrypt and decrypt messages. Symmetric encryption. So same key for both encryption and decryptions. Secret key or private key advantage, easier to implement. You can see on the picture right side is faster. Disadvantage is key distribution. So symmetric algorithms are a form of encryption that is older and a simpler method of encrypting information. The basis of symmetric encryption is that both the sender and receiver of a message have previously obtained the same key. This is in fact the basis for even the oldest ciphers. The Spartans needed the exact same size cylinder, making the cylinder the key to the message, and in shift ciphers, both parties need to know the directions and amount of shift being performed. All symmetric algorithms are based upon the shared secret principle, including the unbreakable one-time paired method. So you can also see in the picture, the simple diagram shows the process that a symmetric algorithm goes through to provide encryption from plain text to ciphertext. So this ciphertext message is presumably transmitted to the message receiver, who goes through the process to decrypt the message using the same that was used to encrypt the message. Okay. So unlike the hash functions, a cryptographic key is involved in symmetric encryptions, so there must be a mechanism for key management. Managing the cryptographic keys is critical important symmetric algorithm because the key unlocks the data that is being protected. However, the key also need to be known or transmitted in a secret way to a party with whom you wish to communicate. This key management applies to all things that could happen to a key: securing it on the local computer, securing it on the remote one, protecting it from data corruptions, protecting it from loss, and probably the most important step, protecting it while it is transmitted between the two parties. We will discuss this in the later on topic. So symmetric algorithms are important because they are comparatively fast and have few computational requirements. Their main weakness is the two geographically distant parties both need to have a key that matching exactly. In the past, key could be much simpler and still be secure, but with today's computational power, simple key can be brute forced very quickly. This means that larger and more complex keys must be used and exchanged. This key exchange is difficult because the key cannot be simple, such as a word, but must be shared in the secure manner. It might be easy to exchange a 4-bit key such as B in hex, but exchange like 128-bit key is like a 128-bit 4 key, 4B364 40 20C etc. etc. So is for more difficult to do securely. This exchange of key is greatly facilitated by asymmetric or public key or cryptographic, discussed after modes of the operation. Okay, we will discuss this later on topic. Symmetric encryption ciphers is a block and stream. So block versus stream. When encryption operations are performed on data, there are two primary modes of operation: block and stream. Block operations are performed on blocks of data, enabling both transpositions and substitutions operation. So this is possible when large pieces of data are present for the operations. Stream data has become more common with the audio and video across the web. The primary characteristic of a stream data is that it is not available in large chunks, but either bit by bit or byte by byte pieces too small for block operations. Stream ciphers operates using substitutional only and therefore offer less robust protection than block cipher. So you can also Google it to know more about this. Key strength. The strength of cryptographic functions typically depends upon the strength of key. A larger key has more entropy and adds more strength to your encryptions. Because different algorithms uses different methods with a key, direct comparisons of key strength between different algorithms is not easily done. Some cryptographic systems have fixed key length such as 3DES, while others such as AES have multiple lengths, AES 128, AES 192 and AES 256 like that. So length and complexity of the key, longer is more secure. Key entropy is a randomness generated through pseudo-random numbers, initial vector and nonce. So these all are under the key strength. Key exchange. Cryptographic mechanism use both an algorithm and a key. With the key recurring communication between parties in symmetric encryptions, the secrecy depends upon the secrecy of the key. So insecure transport of the key can lead to failure to protect the information encrypted using the key. Key exchange is the central foundational element of secure symmetric encryption system. Maintaining the secrecy of symmetric key is the basis of secret communications. In asymmetric systems, the key exchange problem is one of key publications. Because public keys are designed to be shared, the problem is reversed from one of secrecy to one of publicity. Early key exchange were performed by trusted couriers. People carried the keys from sender to receivers. One could consider this form of key exchange to be the ultimate in out of band communications. With advent of digital methods and some mathematical algorithm, it is possible to pass keys in a secure fashion. This can occur even when all packets are subject to interceptions. The Diffie-Hellman key exchange is one example of the type of secure key exchange. The Diffie-Hellman key exchange depends upon two random numbers, each chosen by one of the parties and kept secret. Diffie-Hellman key exchange can be performed in band even under external observations, as the secret random numbers are never exposed to outside parties. Okay. Session ephemeral keys. Session keys are randomly generated both encryption and decryption during the communication of session between two parties. So a session key is a symmetric key used for encryption message during communication session. So it is generated from random seeds and is used for duration of communication session. So when correctly generated and propagated during session setup, a session keys provide significant level of protection during the communication sessions and also can offer perfect forward secrecy. Session keys offers the advantage of symmetric encryption, speed, strength and simplicity, and with a key exchange possible through digital methods, significant level of automated security. And then ephemeral keys. So ephemeral keys also only used for one session, common to ephemeral keys agreement protocol. So ephemeral keys are cryptographic keys that are used only once after generation. When an Ephemeral keys is used as part of the Diffie-Hellman scheme. It is form of ephemeral Diffie-Hellman key exchange. An EDH key exchange generate a temporary key for each connections, never using the same key twice. This provides for perfect forward secrecy. So asymmetric encryptions uses two keys, one to encrypt, the other to decrypt. Keys are mathematically related. Public-private keys encryption. So asymmetric algorithm compromise types of cryptographic, more commonly known as public key cryptographic. Asymmetric cryptographic is many ways completely different from symmetric cryptographic. While both are used to keep data from being seen by unauthorized users, asymmetric cryptographic uses two keys instead of one. It was invented by Whitefield Diffie and Martin Hellman in 1975. The system uses a pair of key, a private key that is kept secret and public key that can be sent to anyone. So this system security relies upon resistance to reducing one key given the other, and thus retrieving the plain text from the ciphertext. Public key systems typically work by using complex math problem. One of the more common method is through difficult of factoring large number. These functions are often called trapdoor functions, as these are difficult to process without the key but easy to process when you have the key. The trapdoor through the function, for example, given a prime number says 293 and another prime such as 307, it is an easy function to multiply them together to get 89,941. Given 89,951, it is not simple to find the factor 293 and 307 unless you know one of them already. Computers can easily multiply very large prime with hundreds or thousands of digits but cannot easily factor the product. The strength of this function is very important because an attacker is likely to have access to the public key. He can run tests of known plaintext and produce ciphertext. This also instant checking of guesses that are made about the keys of the algorithm. Or say Diffie-Hellman, elliptic curve cryptographic ECC, and EIG, Ephemeral are all populated asymmetric protocol. Asymmetric encryption enables digital signatures and also correct the main weakness of symmetric cryptographic. The ability to send messages securely without sender and receiver having had prior contact has become one of the basic concerns with secure communication. Digital signatures enable faster and more efficient exchange of all kinds of documentations, including legal documents. With strong algorithm and good key length, security can be assured. Asymmetric cryptographic involves two separate but mathematical related keys. The keys are used in opposing fashion. One key undoes the actions of the other, vice versa. So you can see on the picture is one of the good best example. Asymmetric keys are distributed using certificate. A digital certificate contains information about the associations of public key to an entity, and additional information that can be used to verify the current validity of the certificate and the key. When keys are exchanged between machines, such as during an SSL TLS handshakes, the exchange is done by passing certificate. Okay. So let's go for digital signature non-repudiation. The digital signature is a cryptographic implementation designed to demonstrate authenticity and identify associated with the message. Using public key cryptographic, a digital signature allows traceability to the person signing the message through the use of their private key. The addition of hash codes allows for the assurance of integrity of the message as well. The operation of a digital signature is combination of cryptographic elements to achieve a desired outcome. The steps involved in digital signature generated and using the message to be signed in hashed, and the hash is encrypted using the sender private key. Upon receipt, the receipt can decrypt the hash using the sender public key. If a subsequent hashing of the message reveals an identical value, two things are known. First, the message has not been altered. Second, the sender possesses the private key of the named sender, so is presumably the sender him or herself. You can also see in the picture, a digital signature doesn't by itself protect the content of the message from interception. The message is still sent in the clear. So if confidentiality of a message is requirement, additional steps must be taken to secure the message from eavesdropping. So this can be done by encrypting the message itself or by encrypting the channel over which is transmitted. Okay. Public key infrastructure. A set of rules, policies and procedures needed to managing public key, asymmetric encryptions. The process of creating, managing, distributing, storing, using and revoke keys and digital certificate. So the picture you can see that it gives you a clear idea. Hashing. Hashing functions are commonly used encryption method. A hashing algorithm is special mathematical functions that perform one-way encryptions, which means that once the algorithm is processed, there is no feasible way to use the ciphertext to retrieve the plaintext that was used to generate it. Also, ideally there is no feasible way to generate two different plaintexts that compute to the same hash value. You can see on the picture. Common use of hashing algorithm are to store computer passwords and to ensure message integrity. The idea is that hashing can produce a unique value that corresponds to the data entered, but the hash value is also reproducible by anyone else running the same algorithm against the data. So you could hash a message to get a message authentication code, and the computational numbers of the message would show that no intermediary has modified the message. This process works because hashing methods are typically public and anyone can hash data using the specified method. It is computationally simple to generate the hash, so it is simple to check the validity or integrity or something by matching the given hash to one that is locally generated. HMAC or hash message authentication code, we can say like that, in short as HMAC, is a special subset of hashing technology. It is a hash algorithm applied to a message to make a MAC. Okay, so messaging authentication code. Okay, so but it is done with a previously shared secret, so the HMAC can provide integrity simultaneously with authentication. A hash algorithm can be compromised with what is called a collision attack, in which its attacker finds two different messages that hash to the same value. This type of attack is very difficult and requires generating a separate algorithm that will attempt to find a text that will hash to the same value of known hash. This must occur faster than simply editing characters until you hash to the same value, which is brute force type attack. The consequence of hashing hash functions that suffers from collision is that integrity is lost. If an attacker can make two different inputs purposefully hash to the same value, she might trick people into running malicious codes and causes other problems. Popular hash algorithm are the secure hash algorithm SHA series, or then RIPEMD RIPEMD algorithm, and the message digest MD hash for verifying MD2, MD4, MD5. So hashing functions are very common, that they and they play an important role in the way information such as password is stored securely and the way in which message can be signed. By computing a digest of the message, less data needs to be signed by more complexity asymmetric encryption. And this still maintains assurance about message integrity. This is the primary purpose for which the protocol were designed, and the success will allow greater trust in electronic protocol and digital signature. Hashing issues: pre-computing hash values of common words. Example: rainbow table solved. And then you can use the website crack stations. There is one of the best the website. You can use hash to crack it. So collision attacks tries to find two input strings of hash functions that have the same output. Elliptical curves, quantum cryptographic. Elliptical curve cryptographic is an algorithm as an asymmetric public key crypto systems based on complex mathematical structure. As I said before, uses smaller key size very fast. Quantum cryptographic relies on physics rather than mathematics, based on the quantum state or photons, more secure. Use of proven crypto algorithm. NIST maintains publications and guidance for use of approved cryptographic and hash algorithm. Crypto best practice. For crypto best practice, use well-known and approved cryptographic algorithms. Adhere to record minimum key guidance for the chosen algorithm. Use approved cryptographic codes. Use strong random numbers generator. Obfuscations, steganographic. First, obfuscation. Obfuscation is masking of an item to render it unreadable yet still usable. Consider source code as example. If the source code is written in a manner that is easily understood, then its functions can easily recognize and copy it. Code obfuscation is the process of making the code unreadable by adding complexity at time of creations. This mangling of code makes it impossible to easily understand, copy, fix, or maintain. User cryptographic functions to obfuscate material is more secure in that it not reversible without the secret element, but this also renders the code unusable until it is decoded. Program obfuscations can be archived in many forms, from tangible C functions with recursions and other indirect reference that make reverse engineering difficult, to proper encryptions of secret element. Storing secret elements directly in a source code doesn't really obfuscate them, because numerous methods can be used to find hard code secret in a code. Proper obfuscation requires the use of cryptographic functions against non-reversible element. An example is storing of password hashes. If the original password is hashed with the addition of a salt, reversing the stored hash is practically not feasible, making the key information the password obfuscated. Steganographic. Steganographic, an offshoot of cryptographic technology, gets its meaning of the Greek word stegnos, meaning covered. Invisible ink placed on a document and hidden by anonymous text is an example of steganographic message. And another example is a tattoo placed on the top of the person's head, visible only when the person's hair is shaved off. Hidden written in the computer age relies on a program to hide data inside other data. The most common application is the concealing of a text message in a picture files. The internet contains multiple billions of image files, allowing a hidden message to be located almost anywhere without message discovered. The nature of the image file also make a hidden message difficult to detect. While it is most common to hide message inside image. They can also be hidden in video and audio files. The advantage to steganographic over cryptographic is that the message do not attract attentions, and this is difficult in detecting the hidden message provide an additional barrier to analysis. The data that is hidden in steganographic message is frequently also encrypted, so should it be discovered, the message will remain secure. Steganographic has many uses, but the most published uses are to hide illegal material, often pornographic, and allegedly for covert communication by terrorist network. Terrorists have used steganographic to distribute material through the web, and the techniques have been documented in some of their training material. Steganographic encoding can be used in many ways and through many different media. Crypto uses case. So, crypto services are being employed in more and more systems, and there are many common use case associated with them. Example including implementation to support situations such as low power, low latency, and high resiliency, as well as supporting functions such as confidentiality, integrity, and non-repudiation, data at rest, and also data in transit and data in use. So these all are. So we were discussed about this CAA, confidential, integrity, availability in the previous chapter. I mean, maybe the module domain 2 or domain 3. If I'm not sure, if I'm correct. So we will see the common crypto use cases. Low power device. So low power device such as module phones, portable electronics, and ambiguous or recurrent cryptographic functions. So because cryptographic functions tend to take significantly computational power, special cryptographic functions such as elliptic curve cryptographic are well suited for low power applications. Low latency. Some use case involves low latency operations requiring specialized cryptographic functions to support operations that have extreme time constraints. Stream ciphers are examples of low latency operations. High resiliency. High resiliency systems are characterized by functions that are capable of resuming normal operational conditions after external disruptions. The use of cryptographic model can support resilience through a standardized implementation of cryptographic flexibility. Support confidentiality. Perfect data from unauthorized reading is these definitions of confidentiality. Cryptographic is a primary means of protecting data confidentiality at rest, in transit, and in use. Support integrity. Integrity of data is needed in scenarios such as during transfer. Integrity can demonstrate that data has not been altered. The use of message authentication code MAC supported by a hash functions is an example of cryptographic service supported integrity. Support obfuscation. Supporting obfuscation. There are times where information need to be obfuscated, protected for casual observations. In the case of program, obfuscations can protect the code from observations by unauthorized parties. It is common for computer program to have variable and functions names changed to random names, masking their use. Some people will written down things like pin code but change the order of the digits so it is not immediately obvious. Supporting authentications. Authentication is property that deals with the identity of a party, be it a user, a program, or piece of hardware. Cryptographic functions can be employed to demonstrate authentication, such as the validations that an entity has a specific private key. associated with a presented public key proving identity. Supporting non-repudiation. Non-repudiation is properly the deal with the ability to verify that a message has been sent and received so that the sender cannot refute sending the information. An example of this in action is seen with a private key holder relationship. It is assumed that the private key never leaves the possession of the private key holder. Should this occur, it is the responsibility of the holder to revoke the key. Thus, if the private key is used as evidenced by the successing of the public key, then it is assumed that the message was sent by the private key holder. Thus, actions that are signed cannot be repudiations by the holder. Resource versus security constraint. Cryptographic functions require systems resource. Using the proper cryptographic functions for a particular functionality is important for both performance and resource reasons. Determining the correct set of security resource constraints is an essential beginning steps when planning a cryptographic implementations. Exam preparations. You are using asymmetric encryptions and want to sign a file to prove you send it and it hasn't been altered. Which key do you use? A. B. Your private key. Answer is B. Your private key. So exam preparations again. So which type of cipher encryption data is fixed length group of bits? Answer B. Block cipher. Okay, that's it guys for this video. Please subscribe my channel if you haven't. Press the bell button to get more update. Share the video if you like. I'll post more practice lab later on video. See you guys. Bye bye. Have a good day.